Okay. Recording started. As it's just the two of us, it probably will be shorter, like I said before. But hey, you were talking about, was it LLMs you were doing something with?
Yeah, well, I mean, I just tried the only update that I had about Cloud Robotics this couple of weeks is that I tried out a paper that I saw a while ago that is called Rosa from JPL, and it's basically they use Olama to run an LLM, or actually they can connect to any LLM, but they call it through LangChain, which is giving you an API to call multiple LLMs. And then this LangChain has the possibility of calling so-called LLMs that are allowed to use tools. So you have a special annotation in Python for a method. You say this method is a tool, and this other method is a tool. For instance, I did just a very, literally 5 minutes implementation thing. I installed Rosa with pip. I looked at the code. There's an example of code on how you instantiate an LLM that uses Olama, so a local model, and I used a Quen model. And then all you have to do is put an annotation in front of a method that says, for instance, I said, this is the method to set the velocity, the forward velocity of the robot. And then it kicks on this thing, connects to the LLM, and then you can chat with the thing. And since the LLM is able to use tools, you can say to it, please set the robot velocity to 0.1. And all it does is it invokes your Python method, and the body of my Python method was just reusing something that they had already done, which was the most stupid thing you can do. ROS2 topic pub common velocity, velocity with the placeholder with the velocity, and then the robot moved forward with that speed. And then it was interesting because then I right away noticed that it was sometimes working well when you were setting the velocity, and sometimes the LLM would just tell you, okay, I set the velocity to whatever you were saying, but you would see that there would be no call of your method, of the method that I annotated. So I ended up, and it wouldn't stop my robot, because typically when I would say set the velocity to 0 or stop, it wouldn't stop it. It would say, yes, I stopped the robot setting the velocity to 0, but it didn't. And so I tried it again, and and then I realized it's much easier if I have a method set velocity and a method called stop, and then it would catch it. It would understand it. So in the comments of the method, you actually give the comment to the LLM to understand what the method does. And so by then I was quite, I put it on LinkedIn so you can look at it afterwards. It's really, literally took me 5 minutes. So it's the most stupid demo that you can do. But I was impressed because you could now already, with this set velocity and stop method, you can already say to the LLM, please set the forward velocity to X for 5 seconds, and then set velocity backwards to this velocity for 3 seconds, and then stop the robot. And it was actually doing it properly. So it did the first method invocation. Then I don't know what the LLM uses for doing timer. Maybe it just invokes a sleep. I didn't know. I didn't see if Rosa is asleep or something like that. Then it went backwards, and then it stopped the robot. And then it prints out all these nice things. So I was playing with it because I will give it as an assignment in my ROS course class. They would actually have to use that to then call all the things that they learned how to write in ROS. So mapping, navigation, planning the motion of an arm, controlling the gripper. So now I want them to basically write the tools that allow to do all these invocations, and then they will have to do a little demo at the end of the year. But it's a very neat project, and it really takes you 5 seconds to try it. And if you have a simulator of a robot that you typically use, it's fun. It's actually it's actually interesting to try to see the quirks of the LLM and how it works and how it doesn't work.
Yeah, that actually sounds like something I'll look into. I was intending to look into simulator stuff anyway, so attaching LLMs. I like the sound of that. I think that's a blog post, a YouTube video.
Definitely, I was impressed by how little time it took to get something running. Then, of course, you get as with every interaction I have with LLMs, I saw a quote. Maybe I've already said this. I saw a quote somewhere that it was saying that when you're programming with an LLM, rather than their programming, you're trying to persuade the LLM to do what it's supposed to, and it's the case also there. But I also guess it was a limit of the specific LLM I used. I didn't try it. The original paper uses it with ChatGPT, I think. And I haven't tried it with ChatGPT. But now there are so many nice models that you can run locally that you can even try. The next thing I'm going to try, which I'm very interested into, is using a VLM, actually, so a vision language model, because that you can try it. You can use it for validating the action that you have done. For instance, you can say, look at the stream from look at the snapshot from the arm camera. Try to grasp the object, and then after it tries to grasp the object, you can still take a snapshot from the camera and say, am I holding is the robot holding the object? So you can use this to somehow double check whether the intended effect of the action was indeed achieved. So somehow that's going to be the next thing that I will try to do. And after that, I will try to actually somehow use this little functionality that you can have with the VLM to ease the programming. So to somehow use it as a human-robot interface where a human can give much more feedback or control much more what the robot does. At least that's what I will try this summer once the semester is over.
Once you got time for projects again.
Exactly.
Yeah. Well, you're making me want to try your course now.
But the course the course is just a ROS course. So
yeah.
It's, you know all the things already.
Yeah. I heard someone describe LLMs as asking a room full of students who haven't studied for the test to answer questions. So they just sort of make up answers, and some of them together know how to do it. But I think it's really accurate when you look at LLM responses.
Well, for many things, yes. For programming, somehow I have a different impression. Somehow it's really down to, it's like pair programming with a guy that knows all the APIs by heart and has a bunch of snippets of code in its head, and so I find it very productive, because the thing that is time consuming for me, especially that I don't have a horrible memory and I don't program full time, is remembering APIs and seeing how things should be instantiated and all these sort of things, and that you get it for free basically, so it works quite well. And then I was also reading on Twitter and on Blue Sky, the people that are now doing this thing that they call vibe coding. I don't know if you read it.
Yeah.
I haven't tried it. I mean, I don't have much time lately, but if I had a few hours, that's the other thing that I would try. But really, vibe coding in the real definition, which is you don't look at the code.
Yeah, exactly.
You just iterate and make the LLM do all the work. That I haven't tried yet. I mostly still look at the code and the diffs and do the development.
I have been doing some of the LLM guided coding, and what it's really good at for me is copying and pasting code and helping me change the bits that need to be changed. It's really good for that. That's just a lot of sitting there typing that it just completes for you. That's my biggest helper.
Are you using it with an IDE, or are you using it, or are you really copying pasting? Because I found it extremely more powerful in an IDE, because for instance, I used with Visual Studio Code and an extension that is called Klein. And that's very nice. I mean, Klein is also connecting to Claude or OpenAI or any of the things you can use. And it works very well because it basically feeds to the LLM the entire project structure that you have. So it knows all the files that you have, feeds the open windows that you have. So it uses the context. And then when you're asked to modify something, you get a diff. So you get the screen splits in two, you get the original file, the new file with just the diffs, and then you can accept or so it's much more powerful than just copy pasting, because it really just, for every change request that you have, you really see the punctual changing, and no copy pasting is involved. It's just, it modifies even more files than one for each request. So it, for structured projects like what I use usually, it's easier than copy pasting on the web UI. Of course, there's the problem that you need to have access to the API. So typically you need to have a paid access to the API.
Yeah, I used a Copilot in VS Code, and it would have been me copying and pasting, but instead it just guessed what I was trying to do. So that was great. The downside was when I tend to think what I'm trying to do by writing comments in the code, which unfortunately it interprets as either prompts or tries to guess what comment I'm about to write. So I just find it really distracting at that point.
Yeah, I also didn't have a good experience. I mean, I used Copilot very little at the beginning. I didn't also like that it was somehow a sort of autocomplete. I found it too interruptive. I constantly had to stop it, basically. So this is why I like Klein. Klein is really a panel by the side of your window, and you just write the requests for changes that you want to do there. So I wrote a little application using Node.js and some Mosquito client, and I don't remember what else, and it all put it all together by himself. It was very, very nice. I was happy with it. So I would use it. I would also use it more. Unfortunately, though, it worked very well when I was using Claude for doing this. It didn't work as well with the local models that I installed myself, probably because the local models that I had were not powerful enough. And the other thing that I noticed was even for instance, I tried to use the DeepSeek models or what was the other one that came? Gemma, I tried to use also, but somehow they were not really working well with the integration for calling tools, because it's the same thing I was telling before. There's annotations about functionality that an editor can do, and it works in exactly the same way. And somehow I remember anything that wasn't Quen or Claude would somehow get stuck and say, I'm trying to read this file. And then it would get stuck trying to read the file and not using the tool properly. So then it breaks the interaction, and then it's not really worth it anymore. The integration doesn't work somehow, and then you're back to copy pasting, and it's useless.
Yeah.
For me, it's not the right model. It's too interruptive again.
Yeah, that makes sense. Well, I've definitely been reading a lot more online, so I think I need to try more models out. Klein sounds pretty good. But I think the Cloud Robotics stuff that I was going to talk about today, there was a bit of a review on progress, but I don't know how much we can discuss that with the two of us. And we didn't, it wasn't too long ago we last discussed it. The real thing that I wanted to bring up was that I skimmed through the recording from our last meeting where Christian asked the question about deployment, essentially, like how do we do deployment? And even I just listened to it on double speed and found it really interesting. It was like a podcast. And it got me wondering about a possible format for future meetings, which is instead of either we have a talk or we have a general discussion, we can have a list of topics that we've thought about in advance. For example, one I've been thinking about a lot today, because if you remember, I'm writing a talk to give to NVIDIA, which is not yet confirmed, but I'm writing it ready to get the talk booked. I decided to do it about why aren't we using cloud robotics and what can we do about it? And that's the sort of thing that I feel like this group would have a good view on. So that's another example of a topic. So how do we deploy? Why aren't people using cloud robotics? How do we make it better? That kind of stuff. And I figured we could have an issue that we add to with possible suggestions. And having an interesting sounding topic when we announce the meeting might get people to join in, have their say.
Yeah, it's a good idea, I think. I think in the discussion we had the last time, I think Chris also nailed it somehow. Also, the question that you were asking, why aren't people using so much of these tools? Because he was mentioning that, for instance, deploying applications and deploying software on the robot becomes such a critical aspect of every robotic company that you somehow tend to keep that technology in-house at all costs. So you would not be using a third-party tool unless it was completely open source and unless you had full control of it, which somehow then doesn't really make it a good commercial, a good target for a company, basically. I mean, some companies are doing it and are trying it. I didn't listen to again to us three talking, but I did think about it because I thought about something I said there, which is true, that I came to cloud robotics from the cloud, and somehow I have this bias, which might be incorrect in the long run in robotics, where I do see that application in cloud computing, applications are constantly redeployed, and because they're continuous applications, they're typically accessed through an API and accessed through a web interface, and you constantly update them while they're running. But I went swimming last week, Wednesday, and in my local swimming pool, they have a cleaning robot now that cleans the floors. And I was really thinking, as I was swimming and watching the robot driving around next to the swimming pool, I was thinking, this robot doesn't need the application to be updated. maybe every 6 months, right? But I mean, the thing that it does after it has built the map of the swimming pool and where it can go and where it cannot go, and avoiding people, how much more functionality are you going to add to that application? Yes, maybe you do is a better planner, or I don't know what, but that application doesn't need frequent deployments. You deploy it once, you turn the robot on, you make it go back to the charger, and as a matter of fact, probably the least you deploy a new application, the least problems you're going to have in the future. So that's what I was thinking about what I said last week, that somehow if you get your application right for some robots, maybe you don't need to update, or maybe the updates are not so frequent. Not so frequent as to be needing something like the approaches that we saw, like a Kubernetes cluster for redeploying all the pods or all these sort of things. Maybe indeed this view of continuous integration and continuous deployment that I came from cloud computing it's not really needed in robotics, or maybe it's not needed as frequently. Let's put it this way.
It's a good point. I'd argue that you don't know if the pool owners would like some new functionality put into the robot. You see it working. That's a brief window, but yeah, that's a nitpick in what you're saying, which is absolutely fair. Like, it's working. It's got the map. Same as floor cleaning robots in your house. Similar thing. I guess it needs to report the map, so it does still have a cloud connection.
It does. I think Roombas do that, and I think there are new. I don't ever remember the name of this new super cool robot that does the 3D mapping of your house by using the stereo cameras, and never remember the name of that company, but they're really they're really cool. For the swimming pool cleaning robot, I think because I was looking, I didn't find the company that installed it, to be honest, but I'm pretty sure that I saw that the robot is a Chinese robot. It's probably installed here in Switzerland through a reseller. And I didn't check, but the last time I checked, most of the resellers that are installing robots like this, they are using the third-party fleet manager that comes with the robot from the original producer of the robot. So again, there somehow is also something that I was biased, where my understanding was biased, because I always assumed that once you start having multiple robots at the location, you would like to use a fleet management solution that would be open source to somehow manage the different type of robots, a bit like how they do with OpenRMF with in the ROS world. But in practice, maybe there's still not enough robots around here. So in practice, all the robots I've seen that are deployed in restaurants, in hotels, or cleaning robots, most of them are using the original producer fleet management solution, even though they are sold by a third party. So that was, if you want, a missed opportunity for, again, Cloud Robotics, because I thought, if I'm a reseller of robots, I would like to keep the platform, the cloud platform that manages all the robots to myself, so that I know all the robots that I have installed in my country, and I can control all of them, and I can do, I don't know, predictive maintenance or this sort of things. But somehow this doesn't seem to be the case, or at least I have not found a company here that does it that way.
Yeah, I guess that's the amount of effort that it takes to build that platform. You need to be able to make the money from it, and that probably doesn't make a good business case.
Yeah,
that's true. But in terms of deployment being the best, Christian's point about deployment, it's companies have to do it frequently. It's very important. They like to keep it in house. I have a less optimistic view of why companies are doing that. My view is, as I came from doing robotics first and then found out about the cloud afterwards, I think that robotics engineers just don't want to use the cloud. They don't think they need it. That's the core thing. And I think I was thinking about this earlier. I haven't decided whether I think it's true yet, but I think robotics engineers might be even more stubborn than other engineers about writing everything themselves. And I think it's an observed thing in software developers, right? We're here because we like to solve problems. So taking someone else's solution is no fun. So we all want to solve it for ourselves. And then we're kind of like, oh, something exists that solves my problem. Damn it. Now I don't get the fun of doing the puzzle myself. And I think robotics might be even worse for that, because the whole system is new, right? It's not just software. You're also building the robot that's new. You're building the stuff around it that's new. And so the whole mindset of nothing exists for robots yet, I'd need to write it, becomes even more prevalent. So that's...
Yeah, I agree with that. I mean, most engineers think this way, right?
Yeah.
We are engineers because we like problems and we like solving them,
exactly.
solving the problems ourselves. And I'm not a roboticist by background, but I did see what you're talking about in robotics engineers. Indeed, that they somehow, also because robotics is very hard, somehow they tend to say to use their own solutions to do everything else. But I did see this resistance to cloud robotics also early on in the. I think my first Roscon was in Hamburg, so a while back, and I think there were at the Roscons there. I somehow experienced some sort of resistance to cloud robotics. And then less and less. For instance, I remember I don't remember if it was the Roscon in Macau, but there was Formant AI that was giving the keynote, so a cloud robotics keynote, if you want. So the resistance somehow reduced itself at a certain point.
Yeah. I think there's when the engineers will make a robot in the lab, and they'll go, oh, we need to deploy software to it. We need something smarter than SCP. Let's build a Docker container. Let's start hosting our own Docker registry, and now that's more production ready. And I think they build on top of that in layers, not realizing that there are tools that do all of this stuff already. And if you say to them, "Why don't you use the cloud?" they're like, "Oh no, that costs money. It you can't rely on a cloud connection." So yeah, I think a lot of I say this as someone that's come from that world and only having used cloud went, yeah, it's actually probably the right tool.
Yeah. I mean, this is deployment is just one of the aspects, I think. But I see for instance, there's more business. Look at what many companies are doing now, like Foxglove. They're now making an offer about basically collecting data from the robots and storing from the. So that's the other big aspect, especially now that there's a lot of AI that is based on collecting real data, collecting data from the field, and all these sort of things. I think that's also a big thing that is coming, and where the cloud will be very useful. And I don't know how many roboticists are getting this and or are agreeing with this or even seeing it coming. But somehow there's all these discussions now going on about scalability of reinforcement learning and in general embodied AI and where to get the data for embodied AI. And I think the cloud there will also play a big role. I'm not sure through which vendor, or if you need a vendor or just a cloud provider, but I see that happening through the cloud again.
Yeah, definitely. I think the whole LLM stuff happening is almost forcing people to realize that they need to connect to the cloud for something if they want more intelligent robots. So yeah, I guess it's up to us to show them how, if we can.
Yeah, if we can. I mean, we that's a different aspect now. Also, how to collect the data and with which granularity. I that's a thing we didn't really focus on. I think in this working group yet. We looked at how to deploy, but we didn't really look at the different ways in which you are collecting data from the field. Right. That's an aspect we left out.
I like that. I'm going to add that as another topic. What data to collect from the field? Maybe visualization options.
Yeah, we had the talk by Florian Pokorny. His work is more in that direction. Remember where he had this big setup with all these arms that are somehow remotely controlled, and they are collecting all the data from them to then use AI from it. So we touched on that aspect, but we didn't really see what technological alternatives are there for collecting this kind of data, whether you would stream it, whether you would just use raw specs and then synchronize after the robot is finished, or I don't know what other alternatives are there, to be honest.
Yeah, I can only think of caching on an edge server, but at that point, as far as the robot's concerned, it's the cloud. Yeah. Okay. Well, I think the overall question for this session was: shall we start setting topics for particular meetings? And the answer from the one voice I've had
One vote.
Yeah, let's do it. Good idea. So
One vote.
I think what data to collect from the field is an interesting topic. So I think probably the next meeting announcement will be about that. Let's as a Cloud Robotics group discuss what data we think should be collected from robots, what granularity, what it can be used for.
How to collect it exactly. I mean, there's. I think also Eric, when he talked about Fog ROS 2, he mentioned in the future work that he was working on that he was looking at alternative ways to somehow store data coming from robots. So I think we also touched there, but we didn't expand because it was still work that he was unpublished from him. I think maybe he published about it. Maybe it's worth asking him now that if he can disclose about that, because that's the other. I think he was really taking an approach into what kind of alternative to ROS bags and videos and what else you could use to actually store data so that you could reuse it for doing learning.
So was your suggestion just like email him and ask what his opinion is, essentially?
Yeah, we can ask him. We can ask him what he thinks, or we can also look at his paper first and then invite him to present also this one.
Yeah, that's a good idea. Okay, great. Yeah, I'm going to create the GitHub issue for that. List some topics, announce one for next time. And then the other thing that occurred to me that I did want to talk about was we did the survey. We did the State of Cloud Robotics survey. The group's been live for over a year now. Does that mean it's coming up time to do a follow-up?
Yeah, probably.
I'd have to check the dates on that. I'll note that down as well. A follow-up survey.
I think you started it more or less. What was it? February last year or something like that?
Oh, no, we're running late.
Something like that. I don't remember. But I thought it was, around that time. Maybe I'm completely wrong.
Yeah. Okay. I think there's something we can look into as well. I'll check dates on that. Maybe bring it up in a future session. But yeah, I think that's all I had on the agenda. If there's anything you want to continue talking about, that's fine. But, that was the official business.
Good. Any other business? Okay, that was the official business.
Yeah.
Okay.
Any other business? Yeah.
Right.
Parking lot. People suddenly started talking about parking lots when I got to America. It was a new one on me. That's the I really want to talk, but I know I'm holding up stand-up line. Take it to the parking lot. Anyway, let's leave it there then. It was good to catch up. I will definitely take your LLM suggestions. I don't know when I'll get to it. Everything gets added to the to-do list, and then it feels like 6 months later it gets dug up again.
There's so many cool things happening, it's impossible to keep up. So.
Yeah, I don't even have the excuse that I've got a semester to teach. I'm just lazy, I guess. No, I am doing things.
Yeah, but you're doing a bunch of other stuff. I see it.
Oh, okay. That's reassuring. All right, until next time, and thanks for your feedback.
Thank you very much. See you next time.